Hello everyone and welcome to the third tutorial session of Introduction to Deep Learning. Today we will be introducing exercise number 3. We'll be talking about the 3 pillars of deep learning, and we will look at the content of the next few exercises and what you will be implementing. So before we dive into that, one quick reminder: for this exercise you need to use the submission system. If you're external students from LMU or your TUM students who have issues enrolling with the university and cannot register for a course on TUM Online, you have this Google form that we linked to in the previous lecture. We also link from our submission system to this form. If you're one of these students or a TUM PhD student who cannot register for the course, please use that form and you will get a user for the submission system. Again, please use Piazza for questions, both personal and professional questions regarding the content of the lectures. And also, office hours start next week. So starting Monday, we will have at least 1 office hour every day. Actually 2 office hours every day and 1 day with 3 office hours. We have posted Zoom links on Piazza both as an announcement and in the resources. If you look at the staff, you can see each staff member and their office hours. Solutions will be published for each exercise. So this week we will be publishing solutions for the math exercise that was exercise 2. And for exercise 3 that we're releasing today, we will be publishing the solutions next week once the deadline ends. So in general, exercises 3 to 5 are about re-implementing all the boilerplate code for training neural networks. So we will implement classes for datasets and classes to load these datasets into the model. We will implement a classification pipeline. We will start with standard machine learning models that are not deep, and then we will start implementing neural network by adding layers in a modular way. And we will implement optimizers to train these network. So that's what we mean by re-implementing the wheel. So of course you have great frameworks such as PyTorch and TensorFlow, which have all this code already. They do it more efficiently than we will be implementing it. So the question is, why not just start with PyTorch from the start if we're already going to use it down the line? So yeah, so why spend the effort doing this? The answer is because we don't want neural networks to just be a black box for you. So it's often very easy to train neural networks. You just go online, you find these guides that show you a short Python script to train your own neural network. But what happens is that if something doesn't work, or if you have to adapt it or change something or optimize something there, you won't really know what's going on under the hood. So hopefully into the lecture you will know what's inside this black box and what happens with this code and how you can change it. That's often, though, not the case. And even when we train neural networks in research, it's still sometimes a black box, and we don't exactly know what always happens there. But what we hope is that by implementing this yourselves and implementing everything from scratch, you will have a better understanding and more experience when you have to look into these things. So the next question is, why are we using Python for this? Some of you don't know Python and have worked with other languages, but the simple answer is Python is super easy to write code in. It's very short time to proof of concept, and so many frameworks exist for Python for machine learning and deep learning, and also it's probably the biggest language used in deep learning research, definitely in research community, but also if you go and work in industry and you are a deep learning researcher or a machine learning engineer, you will probably be writing code in Python, and only later, if it has to be really accelerated, then there's sometimes a tech transfer team that deploys it onto C++ or something like that, but mostly everyone uses Python, and that's why the course is in Python. So now we want to talk about the 3 pillars of deep learning. So the first one is data. And in data, we think of data sets, which is the actual data that you will be training on, and data loader. So if, for example, this is what your data set is, so it's, in this case, we take the regression that you had in lecture 2. So in this case, the data is pairs of points, x's, and y's, which are what you want to regress. So these are kind of the labels here in this task. And the second pillar will then be the model, which is both the network that does the prediction, but also the loss function or the objective function or the cost function you're trying to minimize. So that is how you evaluate your model. That's how you evaluate its performance on the data. And if you go further with the example of regression, so for example, this is what the loss function would be. So in this case, you just have the square error, so that's what we're minimizing here. And the model which actually performs the prediction is just a linear model here. So it's just the theta that's multiplied by the input x plus some bias. So that's linear regression if you break it down into these 2 pillars. And then, of course, there's the solver, which actually is responsible for finding the right parameters for the model. So from an implementation point of view, it will be the script that runs the whole training loop. It will be the optimizer, which does the gradient steps and finds the optimal thetas for this task. And it will also, part of the training script will be validation, which is what you do throughout training to see that you're getting better results on unseen data, and visualize your outputs throughout training and see that your model is doing what it's supposed to as you train it. So if we look at the first pillar, the data, and the first element there was the data set. So the data set stores the data, hopefully in an efficient, accessible way. And we usually do a lot of pre-processing once before we train our networks. So for example, if you have to do cropping and resizes of the images, so they're all in the same size that you can train on, you do this either once offline, or you do this online as you load the data into the model. And for example, we can take images. So we call this an image folder dataset. It's basically a folder that has images that we want to train our model on. So here you have a folder with many images of cats. And on the very left, it's just a simple folder. But if you already arrange it in this way, where you have each image and then a corresponding label. So here they're all cats, but it could be mixed with cats and dogs. So you would want this to be a cat and the label cat, and then if you have a dog image, then the label dog. And then you want to be able to access it efficiently, so that if you request element number 2 of the data set, you get the second one, and you have easy access to the image and the label during training. So you have to take this data and feed it into the model somehow. And that is exactly what the Dataloader class is going to be doing. So it defines how to load the data set for model training. One important thing when you're doing stochastic gradient descent is the randomization of batches that you use for training. So you don't always traverse your data set in the same order that it's stored in, because you want to add stochasticity. And sometimes you cannot look at all the data set at once because it's just very big and it doesn't fit into memory. So the Dataloader class will take the data set, it will shuffle it or read it in a shuffled manner, and break it down to smaller pieces, which we call mini batches, and we'll load them into the model. So here you see the data set entirely, and then here we're shuffling the indices that we're going to sample, and then we're dividing it into mini batches. So you see here for the first mini batch we have indices 3 and 1, and then it's providing the model with x3, which is the input of sample number 3, and y3, which is the label, and the same with 1 here. And the same happens with the next mini batches. And basically you will be doing an optimization step on each of these mini batches. So these are the things we want you to implement in exercise 3, basically. So if you look at the folders in exercise 3, you will see 2 notebooks. The first one is with the dataset, Cipher 10. It's images, and there's another notebook for a Dataloader class. And this is your first submission that counts for the bonus. And you have to do both notebooks, and the script creates one zip file that you upload to our submission system. And please note that there is a fixed deadline. So the deadline is Wednesday, May 5th at right before 4 p.m. So the submission system will close at 3:59. We advise you to submit it way ahead. There could be issues. This is also the first bonus submission, so there might be hundreds of students who are trying to submit it at 3:30 p.m. So yeah, it's a good idea to do it ahead of time. Here there is no actual model to run, so we don't expect the submissions to take very long to process, but still just take it into account. We're not planning on giving any extensions, so please don't email us if you didn't manage to do it on time. This is also a reminder you have one free card to use, so if you don't manage to submit one exercise, that's still fine. You can still get the bonus. But then if you don't do this one, you have to do all the other exercises. All right. Some comments about notebooks. We've been getting questions both privately and on Piazza about running these notebooks. So a few important things. It's important you run the cells from the top to bottom, because sometimes in a cell somewhere down in the notebook you will need some output that was calculated in the first cells, and if you don't reevaluate the first cell when you open the notebook again, you might not have it and get errors. So always run it from the start to get all the outputs correctly. The second one is be careful when changing notebook cells. So we designed the exercises such that most of the code you change is in these blocks in the files that are outside of the notebooks in the exercise code folder, and you don't really have to change code in the notebooks, but you can just be aware of what changes you're making and if it messes anything up. And when you do code in the exercise code, you should not be coding outside of these boxes that you see in the code. So wherever you have to write code, you will see these to-dos that are very visible, and this is where you should write code. So the exercise is possible by writing code in these boxes only, and you don't have to write anything outside. The next thing is looking at other parts of the code. So if you look at the exercise code folder, you will see more files that you don't necessarily code in. But sometimes in the notebook, you will see these green labels where we say check code. And we advise you to actually have a look at this code because it's important. It might help you later to understand what's not working and debug. So look out for these green boxes. All right. So back to these 3 pillars. You're going to be implementing in this exercise the first one, the green one on the left, the dataset and the Dataloader, and a lot of this code will be used in the future too. So the gray ones here, namely the Dataloader, the loss functions, and the solver, are useful for many different projects that you might be working on. So the data sets can change and the models change, the architectures of the networks that you're using change. But what we're working on now is kind of boilerplate code. So it might be also useful for you in the future, but for sure also in future exercises we will be building upon the code that you're writing now. Yeah, that's mainly it for today. So in the next lecture, which is on Monday, you will be talking about backpropagation. And then next Thursday, we have exercise 4 that we will be introducing, which implements the solver pillar of deep learning. And we will be implementing an optimizer and a training loop. So yeah, don't forget exercise by Wednesday. We have the summary here. On Wednesday, you have to submit exercise 3, which is about data loaders. Please watch also lecture 4 next week. And next Thursday, we have the tutorial. Okay, see you next week.